Hello friends, I, BHATIA, welcome you to my YouTube channel, Maths DNA from origin to infinity. In this video, we are going to discuss a question of real analysis for the examination of Csir-Net mathematics. But before that, let me share something with you. We believe that to qualify this exam, you just need to follow 3 simple steps: prepare, practice, and perform. For more details about this, you can register on our website as well as contact us from our WhatsApp number. Moving on to the question. The question is the function fx equals to sine inverse cos x is, and the options are A. Continuous at x equals to 0, B. Discontinuous at x equals to 0, C. Differentiable at x equals to 0, and option D, none of the above. For the solution of this question, we need to go to the definition of continuity once and then differentiability. In each and every paper, you can easily find at least one question asked on this topic of continuity and differentiability. So I personally recommend you to go through all the such type of questions of this topic and prepare them. Now, moving on to the solution. Firstly, for continuity at x equals to 0, so it should be limit left hand limit exists, right hand limit exists, and the value of the function at that particular point should be same. That is, limit x tends to 0 plus sine inverse cos x should be equals to limit x tends to 0 minus sine inverse cos x should be equals to f of 0, the value of the function at that point. Here we take limit h tends to 0 sine inverse cos 0 plus h should be equals to limit h tends to 0 sine inverse cos 0 minus h, and should be equals to sine inverse cos 0, the value of the function at 0, which further implies limit h tends to 0 sine inverse cos h equals to limit h tends to 0 sine inverse cos minus h, which is equals to sine inverse cos 0. Now cos is an even function, so the minus sign does not affect it, so we get limit h tends to 0 sine inverse cos h equals to limit h tends to 0 sine inverse cos h, and which is equals to again sine inverse cos 0, which all give the value as sine inverse 1, sine inverse 1, and sine inverse 1. Here all the three values, that is left hand limit, right hand limit, and the value of function are equal. So clearly the function is continuous at x equals to 0. So option A is correct and B is incorrect. Now for the differentiability of the function at x equals to 0, firstly we differentiate the function. The differentiation of sine inverse x is 1 upon 1 minus x square, so here it is cos x, so 1 upon under root 1 minus cos square x into, using chain rule, differentiation of cos x will be minus sine x, which further simplifies to minus sine x upon under root sine square x, which is nothing but minus sine x upon mod sine x. Now depending upon the value of x, we have our function f dash x equals to minus sine x upon sine x, that is equals to minus 1. If x is greater than 0, definitely the modulus in the denominator will be plus, and if x is less than 0, sine being an odd function, it will be minus sine x upon minus sine x, and that will be equals to 1. So we have two different values of our differentiable function, minus 1 if x is greater than 0 and 1 if x is less than 0. Now as per the definition of differentiability, both left hand limit and right hand limit should be equal, that is the limit of fx minus fc upon x minus c should exist, but here it will not exist as the left hand limit and the right hand limit are unequal or different. Thus the function is not differentiable at x equals to 0. Hence the correct answer is option A. Thank you. Now one question for your practice. The function fx equals to e raised to minus mod x is, again, A. Continuous at x equals to 0, discontinuous at x equals to 0, differentiable at x equals to 0, and option D, none. Go through the definition once again and try to solve this question by yourself. Comment your answer below in the comment box, and the solution of this question will be provided in the next video. Till then, you can be a member of our social club and watch 510 plus videos on our YouTube channel. can get a complete study material for any higher mathematics competitive exam from our WhatsApp group.